Alright, this is 3.7 part 1 notes. The objective is that you can graph an absolute value function. Alright, a couple key terms and definitions that we should probably know about. The first one is an absolute value function. An absolute value function, we've kind of actually already talked about these, but whenever we're talking about graphing, which is what this whole one is about, is the graph is going to look like a V. It's going to look like a V. Or it might be like an upside down V, but that's going to be an absolute value function. The vertex is a point on a graph where it changes, where your line or whatever your shape changes directions, where shape changes directions. And we'll see what we talk about. In this place, for absolute value, it's pretty straightforward, but whenever we get into other ones, it's a little more subtle. Vertex form of an absolute value function is f of x equals a absolute value of x minus h. That's kind of a big thing right here, that x minus h, absolute value, plus k. Couple things that we need to know about whenever we're talking kind of vertex and stuff like that with the absolute value is our domain is going to be all real numbers. And our range uses the vertex. And it's always going to use the vertex. And I don't use the word always very often. Always uses vertex. Let's look real quick at an absolute value equation, and we're going to look at is what's called the parent function. The parent function is kind of your most basic equation that everything else can kind of stems from. And so a parent equation is, in this case, the absolute value of x. And so what I'm going to do is I'm going to graph a few of these. And whenever I'm doing this, I'm going to take probably about 3 to 5, just depending. But I'm actually going to do 5 on this one. The one that I always try and start with, if possible, is 0. Why? Because 0 is kind of easy. So I got -2, -1, 0, 1, and 2. The absolute value of 0 is 0. The absolute value of -1 is 1, 2, 1, and 2. So if I graph this, it's going to look like this. It comes straight down, and right here it changes direction, and that's what we call a vertex. My domain is all real numbers. And my range is you can write this as 0 is less than or equal to y, which is less than or equal to infinity, because we go to infinity. You might also think of this as y is greater than or equal to 0, and you're not going to be wrong there. Okay. All right. What we're going to do is we're going to talk a little bit about what are called transformations. The transformations is how this has changed. So, sorry, how much has this changed when we're looking at it? And so the way that we look at this is we kind of utilize that vertex form. And so, like I said, so for number 1, let's just write it out first. So g of x equals the absolute value of x minus 2, absolute value, plus 3. So the first thing that we can get is we can get the vertex. The vertex is given by h and k. Let me use, this is going to be our h, this is going to be our k. And so our vertex is located at 2, 3. And what you'll notice is if I get rid of these lines, is this says -2, but I said it was 2, and kind of the way that I look at it is what makes the inside of this 0, and that is 2. And then it's just kind of the straight K. And so what this means is that we've gone right 2 and up 3. And so if I were to graph this, it's going to look like this a little bit. So I go right 2, 1, 2, go up 3, 1, 2, 3, and this is where my vertex is now located. There's a couple other things in here. We have an A, but it's 1 over 1, so that tells us our slope for both sides. It's up 1 over 1. It's up 1 over 1. And so we have this little tiny thing, and it goes on forever. Okay. Let's do number 2. Number 2 has f of x equals the absolute value of x plus 1, close the absolute value, minus 5. So what we get from that is that our vertex, if I look at this, x plus 1, it actually means that that is going to be -1. Again, what makes x plus 1? What do I need to put in for x to make that 0? That's -1. And then just the outside, so minus 5. I don't have any thing on the outside, so that tells me that it's kind of an invisible 1 out of 1. My transformation then is left 1, down 5. So if I graph this, I can make it a high graph. So left 1, down 5. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. Right there. Nothing else about it has changed though. So my rise and my run is still 1 and 1. So I can graph this like so. Number 3. H of x equals negative absolute value x minus 1 absolute value minus 7. Now we suddenly have something in that A position, but that actually doesn't affect us finding our vertex. Our vertex is still given by what makes the inside of the absolute value function 0, so in this case 1, and what's on the outside, so minus 7. And so transformation-wise, this says right 1, because this is a positive 1, down 7, and we haven't covered this yet, but this negative makes it open down. So the way that this one graphs, so I'm going to have to make a big graph for this. So right 1, down 7, 1, oops, wrong color. 1, 2, 3, 4, 5, 6, 7. Instead of opening up like the other ones, we're going to go down, like so. Yep. And let's do a couple more examples. So in examples 1 through 4, graph the function, compare the graph to f of x equals the absolute value of x, describe the domain and range. Alright, so looking at number 1, we have, let's see, that's t of x equals 1/2 the absolute value of x. And so we're going to first graph it, and then we'll kind of compare. So I'm going to do the parent function in black. And the parent function is what it was to start off with. And then we'll see what the change is. So go all the way down, go up, point in both directions. Now, we're going to do number 1, and you might want to make a table of values, where you kind of make an X and Y on the side, and you start choosing some. So, kind of like I said earlier, I like to start at 0. And so when I do 0, I'm going to get 0. When I'm at -1, I get the absolute value of -1 is 1, times 1/2 is 1/2. When I go to -2, I'm going to get 1. And I'm going to get the same things on the other side. Oops, not 2, 1. So 1. And so if I graph this, I'm at 0, 0. I'm at 1 and then 1/2. 2, I'm at 1. And you can kind of see it's come down a little bit. And so we actually have a phrase for that. So in comparison, when I say compare, what we call this is a vertical shrink. Now, depending on kind of your teachers and stuff like that, you may also hear of this as a horizontal stretch. However, for the math classes that I teach, we don't really use this. So, kind of things to know is a horizontal shrink is when we're kind of shorter than what it was, if this is the regular. And then a vertical stretch is when it's kind of closer to that y-axis. Vertical stretch. Normal. Vertical shrink. All right. Next thing that also asks us to do is it wants the domain and the range. The domain is pretty easy. It's all real numbers. All real numbers. And then our range goes from our vertex, which is at 0, and goes all the way to infinity. Number 2 has u of x, of x, not absolute value, of x equals negative absolute value of x. Eventually, you might get to the point of where you can just look at this and you can identify, oh, this is what's going on. Until then, it's good to graph it. So this is the parent function. Maybe I make an XY table so I can compare, starting at 0. 0, I'm going to get 0. I'm going to get -1. I'm going to get -2. And so what we see is that it opens down. That's the transformation. So the compare is it opens down. Domain and range. All real numbers. The range goes from negative infinity, because negative infinity is less than 0, y, which is less than 0. So there's that vertex again, just in a different kind of look. Number 3, p of x equals the absolute value of x minus 3. So again, I'm just going to draw the parent function. That way I can see the change. Make my xy table. 0, -1, -2, 1, 2. And so I start to fill these in. So I'm going to start with 0. The absolute value of 0 is 0 minus 3 gives me -3. If I do 1, the absolute value of 1 is 1, minus 3 is -2. Absolute value of 2 is 2, minus 3 is -1. I'm going to go the other way as well. It's going to be the same numbers, -2 and -1. So now I'm going to start graphing these, and so I'm going to go to 0, and I'm going to go down 3, 1, 2, 3, and put a point. I'm going to go to 1, -2, 2, -1, go the other side. Oops, wrong spot. And what's kind of cool is this vertex, there's this thing called reflection, and so it's going to look identical on both sides of that. And we'll kind of cover that a little bit later. So going in this direction, going in this direction. And so whenever we're looking at this, what we can say is we can, in our compare, we can say this is shifted down. Or you might just put down 3. That's also fine. Our domain is all real numbers. And our range is going to be from -3, which is less than or equal to our y, which is less than or equal to infinity. Alright, one more type. So number 4 has r of x equals the absolute value of x plus 2. Close the absolute value. So again, I'm going to draw my graph. I'm going to write down my parent function. 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. Go here, go here. All right. Now I'm going to make that XY table. And on this one's going to be a little bit different than what I've been doing in the past. And the reason why, and we'll see it a little bit, is I'm actually going to start with making this middle 2. And so I'm going to start at -2. So I'm going to do -2, -3, -4, and I'm going to do -1 and 0. And you'll see why this kind of works out. So whenever I plug in -2, I go -2 plus 2, absolute value. That's going to give me the absolute value of 0, which is 0. If I do this for -3, that's going to give me the absolute value of -1, which is going to give me 1. If I do -4, that's going to give me the absolute value of -2, which gives me 2. And going down here, I'm also having 1 and 2. And so if I graph this, my 0, I'm up 2. My -1, I'm at 1. -3, I'm at 0. And I go like this. And so when I say my compare, I say that I went left 2. My domain is still all real numbers. And my range, even though we shifted left 2, there's actually not much changed about it, in that it's still that kind of parent values. 0 is less than or equal to y, which is 0, less than or equal to infinity. Close that. Alright, that concludes part 1. Make sure you check with your teacher on what the assignment is. Have a good one.